Okay, test. Good afternoon. So for this today's class, I will try to discuss your Lab 4 questions. Since during the lab this week, many of you asked question on this one on Lab 4. So before that, let me go through the slide. Just a quick one. So I assume that all of you has gone through the video that I have uploaded and the slide on the transformer. So I hope you can see my slide here. Yes. Okay. Can you see my slide here? Can anyone respond?
Yes, sir.
Just okay, good. So before we discuss on the Lab 4, let me go through this one, just a quick one. Chapter 4, Chapter 3 is on transformer. As you know, that in Malaysia, for example, the users of transformer is usually industry, okay, especially related to energy. For public industry, for example, in here is TNB, okay, Tenaga Nasional. So they must have a lot of transformer because it will convey energy voltage from one place to another place. Okay, so as you know, if a voltage as the distance, we reduce the voltage, we send the voltage from one point to another point, it will reduce as the distance along the distance. So the longer the distance, the voltage will decrease. Okay, so for example, from TNB office to residence, there must be distance. So the one that sent from the TNB's office or generator supply is not going to be the same at the residence voltage. So in order to increase the voltage value, so they must use transformer. Okay, the definition here, they call it is a device that transfers electrical energy from one circuit to another through inductively coupled conductor. Okay, can be used to step up, increase, or step down, reduce voltage in a circuit, but with corresponding decrease or increase in current. So if the voltage is up, increase, that means the current also will go up. Okay, this is pictures of transformer from the giant one, the huge one, to the small one, from the industrial use to the home use. Okay, use at home, small one. So you just go through this. Even the video is very interesting actually. They explain in detail. Oh, this is the small one, the basic one. Okay, So consists of winding, primary winding, secondary winding, and then they're gonna be magnetic field. Okay, so depends on the number of winding, it will affect the voltage. Can use it in single phase or three phase. I can just read this. Okay. This one is the basic formula for transformer. E equal to V, voltage. ES secondary, EP primary, and S number of turns. Okay, turns of the winding. Of secondary over primary equal to I, current of primary, divided by secondary. Okay, can go through this. Okay, I will go to the lab. Well, okay, during the lab, you did open and short circuit, right? I just show you the slide. I hope you can see it. Our lab sheet. So the first one is what you did is open circuit test. The second one is short circuit, right? So the question, first one, power factor. Okay, this is for open circuit. So basically for open circuit, if you see the formula here, in here, okay, let's see. We can, okay, this one. If you see the formula here, this is a short, this is open. So basically this one is going to be formula for open, this one for short circuit. Okay, be careful. For open and for short. So first question is power factor. If you look at chapter 2, slide chapter 2. Okay, one reminder, chapter 1, chapter 2, chapter 3. So chapter 1 is a basic for chapter 2. Chapter 2 is a basic for chapter 3. So in order for you to understand chapter 2, you must understand chapter 1. And in order for you to understand chapter 3, you must also understand chapter 2 and chapter 1. Okay, because it's related. Okay, so for example, the first question here, power factor of a transformer, you will not find it in chapter 2 slide, but you will find it in chapter 2 slide, power factor. Okay, so power factor, let's see, how can I write? If you see the slide of power factor, the formula equal to cos theta, right? Or P over S, or P, S is apparent power equal to V times I, right? Recall back the chapter 2. Let me see if I still have the slide here, chapter 2. I have it here, chapter 2. Let's see on the power factor. Power factor. Okay, this one. Okay, can you see the slide here? I just show you the second chapter slide.
Yes, sir.
Can I? Okay. So power factor here, look at the formula there. PF equal to cos theta equal to P over S. What is S? S is apparent power in here. If you go back to S, this one, right? This one is S, apparent power equal to V multiplied with I. Okay. E multiplied with I, and then P just now. Where is it? Power factor. Okay, this one. This one. So PF equal to P over S, S equal to V times I, right? So this one. In here, PF equal to P over P. Where do you get P from? From your result of the experiment. So, for example, the table, from your table. Let's see the first experiment here, from here. Okay, from here. So this is primary voltage. For example, this one is 25 volt. Primary current, for example, you get 0.44. for 4 input power, you get, for example, you get 10 watt. Secondary, yes.
Cannot see your writing.
Are you sure?
Yeah,
But you can see my slide, right?
I can see your slide at the synopsis and theory part only.
Oh, well. Let me reset. Okay. Can you see the slide now? I am writing now. 5.
Yes, sir, yes.
Okay. 4, this is 10. This is example. Huh? This is 10, 0.4. This is just example. So, to find power factor, in order to find power factor in here, just now, PF equal to P over VI. For example, in your experiment, you get P equal to 10, then V equal to 25, but this will depend on your result. Huh? I is the primary current. Okay, I is the primary current. It depends on your data experiment. Eh? I'm not sure, primary current 0.44 maybe. Okay, so get the number here. Okay. The angle. If you see the slide, PF is also equal to cos theta. Also equal to this one then. Right? So theta here equal to inverse cos of this one. You get the angle then. Yeah. That for power factor and the angle. Now C. IC and IM. IC and IC. C stands for coil loss. M is magnetized loss. Okay, it's in the slide. Okay, let me go this back. Okay, let me show you the. Okay, this one. Okay, Okay, this one. Okay, yeah. So this is the, if you see, this is the IC coil loss current. This is the IM magnetized current. This is the IO. Okay, OI1. Okay. The question asking for IC and IM. If you look at the phasors here, this one, especially this one. Okay. You can derive that IC equal to IO cos theta. Yeah. Right. As for the IM equal to IO sine the angle. Right. What is IO? What is IO? IO is the primary current. Primary current, IO. IO is you get from the experiment. Okay. The angle you get from previous answer, the angle. IO you get from the experiment, so you get IC and IM. Coil loss current and magnetized current. Yeah. That is question C. Yeah, question C. Next, construct the phasors diagram. Okay, just put the numbers then. Put the numbers. If they ask you to construct, just put the numbers. Exactly like the table just now. So this is this is V1, this is V2, this is IC. Put the numbers because you have already the value of IC just now. Okay. You also have value for IM, right? IM, this is IM in here. You also have value for IO from the experiment here. And you also have value for angle in here. So basically, if I ask you to construct the phasors, you put the numbers there in the diagram. Okay. Next, the value of equivalent core loss. The value of equivalent core loss. So basically asking for this one. Let me show you. Okay. This is core loss RC. Wait. Okay. This one is core loss RC. The next one, magnetizing reactance XM. Asking for this one. Okay. Okay, since you have already known IC, so IC you get it. So for RC equal to VI over, VI over IC, right? Because V is parallel, so everywhere as long as parallel, the V value is the same. Okay. VI means V1, the input. The one that you get from, you set, if you remember, you have to set V1 into what value? Experiment 1, 230, right? Rotate the variable output voltage control until the voltmeter V1 indicates 230 VAC. So V1, that is VI, input power. Okay, so you get the RC. What about XC? Reactance. So XC is basically the same because it's the same voltage parallel. So divide by IM, magnetized current. You get the IM from previous question. Okay. That will be for question F. Next is question, draw the equivalent circuit for the transformer on no load with all value calculated. No load. So basically no load is the open circuit, right? So basically no load means you draw, well, no load means you draw this one. Okay, why? Okay. You draw this one. Okay. But put the value, numbers. For example, IO. What is the value of IO? You get from the experiment, right? IO. And the value for IC, you have calculated before, and IM. And RC also, you have measured before, you have calculated, and XM. That's all. Okay. Put a number. So IO, for example, equal to 0.06, IC 0.02, IM 0.04, for example, and RC and XM. That's the D. G. Draw the equivalent circuit for the transformer on no load with all value calculated. Okay. Yeah. Now for the second experiment. Is it short circuit? Short circuit. Remember, for short circuit, as given in the table here, you're going to use the formula, this one, short circuit. Okay. First one, R1 and X1. Where is R1? Okay, R1 and X1. How do you find R1 and X1? So R1 related to the power because you also measure power there. So P equal to I of 2 multiplied with R, right? So R1 equal to P I square. P you get from the experiment, also I. I here means I1, primary current. Primary current, the one that you get remember when you rotate the voltage so that the A2 secondary current to become 0.4 ampere. Yeah, 0.4 ampere secondary current. Then you have to measure the voltage and the primary current. So I1 is primary current. Okay. This one for R1. What about X1? Reactance X1. Use this formula then. This one. Okay. So if you use this formula, let's see, we modify the formula there, we expand the formula. We get V1 over R1 equal to, or we have to put this one, equal to R1 plus X1, right? So for X1 equal to, okay, V1 R1, yes, V1 R1, this is wrong. This is not R. This is I. This is I. Okay, minus R1. Okay, V1 you get from the table, from the experiment, your data, V1. I1 also from your data, right? As for R1, just now you get the R1. R1 is from here, R1. Just now you get the R1. R1 equal to P over I1's. Okay. Yeah. You get X1 then. Next question. B. The value of equivalent core loss RC from OC test, open circuit test, from the first experiment. You just basically just copy paste the answer from the first experiment and asking for RC. Asking for RC. All right. From this one, asking for RC. Value of equivalent core loss, the magnetic reactance. So it's asking for RC, you just copy paste, no need to calculate again. So basically RC equal to VI V1 divided by IC. Right. XC equal to V1, VI equal by sorry, this is XM. XC, this is XM. XM. This is RC. Okay. The same answer with the open circuit. Okay, the last one. Draw the equivalent circuit for the transformer on no load with all the value calculated. So basically just have to put the numbers. Put the numbers in here. Okay, this one. Put the numbers. R1, put the numbers, how many ohms. X1, put the numbers, how many ohms. RC is equal to RC in here. XM also equal to XM in here. Okay. Yeah, that's all. That's all. That's all for equivalent circuit for the short circuit of the transformer. Okay. That will be for lab 4. Any questions so far? I'll go deep on the slide next week for chapter 3. We'll discuss in detail, especially for the exercise. Okay. As for now, I think this one will be enough because this lab is also covered on transformer. Okay, try to do as many as exercise on transformer or chapter 1, chapter 2, and we'll discuss all the question. Maybe you have question on next week on Friday, yeah? Friday next week. And then after that, you're going to have a test right after semester break. Okay, no question, eh? If you have no, yes.
Next week we have lab. Do we need to go or online?
Okay. No, next week lab 5 is going to be online. I will upload the lab sheet later. Okay.
Okay, sir.
But we're going to have lab tests later on also. We'll discuss this after the semester break. So we'll finish the lab first, and then after semester break, before your test, you're going to have tutorial also. Tutorial to discuss questions. Then after that, after test, you're going to have your lab test. Okay.
Okay, sir.
Okay, if you don't have any questions, we'll stop here. I'll see you next week then to discuss more on the chapter 3. Okay, yeah? See you guys next week then.
Thank you, sir.
Okay.
Thank you, sir.
Okay.